Welcome to the DIY Honda Garage channel. The Honda Civic 2022 Plus may exhibit symptoms related to the diagnostic trouble code DTC P050D, which identifies a cold start idle speed problem. This code is triggered when the powertrain control module, PCM, detects that the actual engine speed deviates from the target engine speed during QWS operation. The PGMFI, Programmed Fuel Injection System, is primarily responsible for monitoring and adjusting engine performance and speed. A critical aspect of the PGMFI system includes various sensors and components, such as the intake air system and throttle body, which play pivotal roles in maintaining optimal engine performance. When the vehicle experiences a cold start, it's crucial that these systems function accurately to establish the correct idle speed. Misalignment between actual and target speeds may trigger this DTC, prompting a need for thorough diagnostics and potential repairs to ensure vehicle reliability and performance. The error represented by DTC P050D focuses specifically on cold start idle speed issues in the Honda Civic 2022 Plus. Upon detecting an abnormality, the Powertrain Control Module, PCM, stores the DTC, which serves as an indicator for technicians. The PCM continuously monitors engine speed, ensuring it aligns with a predetermined target during operations. This target is crucial for efficient engine performance, especially during cold starts, when the engine is adjusting to optimal running conditions. Key components, such as the intake air system, throttle body, and various sensors, are instrumental in this precision and must therefore be inspected thoroughly when troubleshooting this error code. Diagnosing the system accurately helps prevent further complications, which may arise from irregular idle speeds or inadequate performance. In addressing DTC P050D, several potential causes must be carefully examined. First, faulty intake air system components may affect air entering the engine, thus impacting the overall combustion process and engine speed during a cold start. Second, throttle body issues, which may include blockages or dirt buildup, can hinder the valve's operation, leading to insufficient or excessive engine speeds. Additionally, the mass airflow (MAF) sensor plays a critical role in measuring the amount of air entering the engine, ensuring proper fuel adjustments. If it fails, it can directly affect idle speed accuracy. Lastly, the intake air temperature (IAT) sensor's malfunction can also produce misleading readings, impacting the fuel mixture and affecting engine performance. Each of these components should be investigated to pinpoint the root cause of the DTC, promptly and efficiently. Drivers experiencing DTC P050D symptoms may notice distinct irregularities in their vehicle's behavior. A common symptom is erratic idle speed, which can differ significantly from normal levels, causing concerns during stops or idling. Additionally, stalling may occur during a cold start as the engine struggles to maintain a stable RPM. This can lead to frustration and concerns over vehicle reliability. Another potential symptom is engine hesitation, especially during initial acceleration, adversely affecting vehicle responsiveness. Finally, reduced fuel economy may manifest due to the PCM attempting to adapt to incorrect air-fuel ratios as a result of malfunctioning components contributing to the DTC. Recognizing these symptoms is crucial for timely intervention and repair. The first step in troubleshooting DTC P050D involves simple checks of the vehicle's basic operations. Start by turning the vehicle to the on mode, ensuring electrical systems are activated but the engine is off. Following that, allow the engine to cool down until the engine coolant temperature (ECT) sensor 1 value reads 77 degrees Fahrenheit, 25 degrees Celsius or lower. This ensures the system is ready to test cold start conditions accurately. After the engine has been cooled to the correct temperature, start the engine and allow it to idle for at least 10 seconds. While the engine idles, monitor the HDS or Honda Diagnostic System for the OBD status related to the PGM-FI system, and specifically check for DTC P050D. This initial confirmation procedure is critical in determining if the DTC is still present and signifies that further investigation is warranted. Step 2 of the troubleshooting process emphasizes the importance of inspecting crucial components of the intake air system. Begin by thoroughly checking the intake air duct for any signs of damage or disconnection, as improper air entry can lead to undesired engine performance. Carefully inspect all connections in the air intake system to ensure they are secure and free from any potential blockages. A clear pathway for air is vital in achieving the desired engine speed during operation. If any abnormalities or blockages are identified, rectifying these issues should be the next course of action. Otherwise, confirming that these components are functioning as expected allows you to proceed to the next steps in the troubleshooting guide. In this step, thorough visual inspection and maintenance of the throttle body are paramount. Begin by disconnecting the throttle body inlet hose to allow unrestricted access to the internal components. Clean the throttle body to remove any dirt or carbon buildup that may obstruct the throttle plate's movement, which is critical for appropriate airflow. After cleaning, carefully examine the throttle valve and bore for any additional dirt, carbon deposits, or signs of damage like scratches or cracks. These imperfections can severely impact the throttle body's efficiency and engine performance, contributing to the symptoms associated with DTC P050D. Ensuring that the throttle body is cleaned and free from obstruction is crucial for maintaining proper engine idle speed. For Step 4, the focus shifts to the mass airflow MAF sensor functional inspection, which is essential in maintaining proper engine operation. Begin by starting the engine and letting it idle under specific conditions. Ensure that the ECT Sensor 1 temperature exceeds 158 degrees Fahrenheit, 70 degrees Celsius. Place the continuously variable transmission, CVT, in either park or neutral, N, or if equipped with a manual transmission, MT, put it in neutral to establish safe testing conditions. All electrical loads should be turned off during this process to avoid interference with readings. Hold the engine speed at 2,500 RPM for 30 seconds to achieve a stable operating condition. During this time, focus on monitoring the HDS for the MAF sensor readings. They should ideally fall between 4.1 grams per second and 5.7 grams per second to ensure proper functioning. Any deviation here could indicate that the MAF sensor or associated components require further examination or replacement. The fifth troubleshooting step involves a careful inspection of the IAT Sensor 1's function, which plays a pivotal role in engine performance management. Initially, make sure that the engine is cold, reflecting the ambient temperature conditions accurately. Turn the vehicle to the on mode to activate the HDS. Note the ambient temperature to establish a baseline for comparison purposes. Quickly reference the HDS for the IAT Sensor 1. Reading shortly after turning to the on position. The critical aspect is to compare this IAT sensor value against the recorded ambient temperature. A proper functioning IAT sensor will showcase a difference of less than 5.4 degrees Fahrenheit, 3 degrees Celsius. If deviations are observed, it indicates deficiencies in the IAT sensor or its connection, leading to potential miscalculations affecting engine operation and P050D disturbances. After addressing the issues linked to DTC P050D, It's vital to complete the final repair verification stage to ensure all corrections have positively impacted vehicle performance. Begin by clearing the DTC from the vehicle's system using the HDS, a crucial step to reset the computer's parameters. Following this action, monitor the engine idle stability, ensuring that it aligns with expected performance. This is particularly important during cold start conditions, where fluctuations were previously observed. Lastly, conducting a test drive under various conditions will help validate that the vehicle maintains consistent idle performance and does not display any residual symptoms linked to the original error. Only after confirming these metrics can the service be deemed successfully completed. Regular preventive maintenance plays an essential role in mitigating future occurrences of DTC P050D in the Honda Civic 2022. Maintaining routine inspections of the intake air system can help ensure all components perform optimally, which is essential for preventing idle speed problems. Additionally, periodic cleaning of the throttle body and replacing air filters will allow for unobstructed airflow. Ensuring accurate air-fuel ratios during operation. Monitoring the performance of sensors, particularly those linked to air management like the MAF and IAT sensors, can preemptively catch discrepancies before they escalate into more significant issues. Engaging in these preventive maintenance activities not only prolongs the life of the components, but also enhances overall vehicle performance and reliability. In conclusion, comprehending the implications of DTC P050D is essential for maintaining your Honda Civic 2022 Plus. This diagnostic code signifies potential idle speed issues primarily linked to cold start conditions, invoking the involvement of key components including the PCM, throttle body, MAF sensor, and IAT sensor. A systematic troubleshooting approach is crucial for accurately diagnosing and rectifying the underlying issues. Regular preventive maintenance and awareness of the vehicle's operational symptoms can lead to early detection of problems, ultimately improving the reliability and performance of the vehicle. Addressing DTC P050D promptly will not only minimize immediate impacts on driving experience, but will ensure your vehicle continues to operate smoothly and efficiently for years to come. Please like and subscribe to the channel. See you next time!